Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So today we are from group 1. So kita akan buat pembatangan tentang projek atas talian biomaterial. So the journal that we chose is gamma irradiation induced grafting of 2-hydroxyethyl methacrylate HEMA onto ePTFE for implant applications. So this journal is published in the Nuclear Engineering and Technology, Volume 52, Issue 10, on October 2020. So on pages 200 and 2320 and 2337. So the authors are Dr. Nasheed Muhammad Izzah, Noaim Muhammad Razali, Professor Irman Abdul Rahman, and Siti Aisyah Shamsuddin. So firstly, the materials and equipment for this experiment is that expanded PTFE, expanded polytetrafluorine membranes, 2-hydroxyethyl methacrylate, HEMA, methanol, ammonium ion 2, sulfate hexahydrate, deionized water, so XPS, FTIR, and EDX for analysis. So the protein absorption study chemicals are bovine serum albumin, NaCl, KH2PO4, and Na2HPO4. For the stimulated body fluids, the SPF is the NaCl, HCl, NaHCO3, K2HPO4 with 3H3O, Na2SO4, KCl, magnesium chloride with 6H2O, calcium chloride, and tris-hydroxymethyl aminomethane. So the grafting procedure is as follows. So various concentrations of the HEMA were used throughout the experiments by adding 20 milligrams of more salt. The ePTFE was cut into dimensions, and for the tensile test, the membrane was cut into a dumbbell shape. The prepared ePTFE was immersed in the monomer solution. All test tubes were covered with parafilm and degassed with nitrogen for 15 minutes to purge the oxygen from the solution. The sealed test tubes were irradiated by gamma rays at 25 degrees Celsius with radiation. Following the irradiation process, the samples were washed with hot methanol at 40 degrees C and were further washed with deionized water to remove any homopolymer gel or unreacted monomer that only physically grafted onto the ePTFE surfaces. The ePTFE was then left in deionized water overnight. The sample ePTFE grafted with HEMA, the ePTFE grafted HEMA, was dried in the desiccator jar until a stable weight was achieved. Each parameter was then recorded in a triplicate. It's recorded 3 times. So the dose rate used for the experiment was for the HEMA 2 sample is 2 kg, HEMA 5 sample 5 kg. The optimal parameter is 2 kg at 30% concentration of HEMA. HEMA 2 30 minutes is sample of 2 kg and HEMA 5 30 is sample 5 kg.
So, 2 in vitro testing methods were conducted in this experiment to analyze the data. Firstly, they used the protein absorption test. The purpose of this test is to evaluate biocompatibility of untreated and grafted ePTFE for use as implants. It was conducted on both untreated ePTFE and grafted ePTFE. Then they analyzed the samples using SPS survey and narrow scans. The other test is SBF test, which is simulate body fluid test. The purpose of this test to evaluate mineral formation on grafted ePTFE. So in this test, the untreated and grafted samples were immersed in the SBF solution for 2 weeks. After 2 weeks, the samples were removed and dried in the desiccated jar until a constant weight was achieved. Then the deposition of mineral on ePTFE surface was measured by the increase of the sample weeks, and the samples were further analyzed using the FTIR, FESEM, EDX, and XPS. So the result of this test is For protein adsorption test, grafted ePTFE HEMA230 samples show N peaks, indicating protein adsorption, while untreated ePTFE show no N peaks. So this means grafted ePTFE effectively absorb proteins, which was indicated by the presence of N peaks in XPS compared to untreated ePTFE. For SBF test, grafted ePTFE HEMA230 samples show 35% weak increase, indicating mineral formation. FTIR and SPS analyzed confirm hydroxyapatite formation, while EDX analyzed detect mineral like calcium, phosphorus, magnesium, and sodium with calcium to phosphorus ratio of 1.94. So the grafted ePTFE induced effective mineralization in SBF. The conclusion of the study is to demonstrate the successful grafting of HEMA onto ePTFE using gamma radiation, which alter the initial properties of the ePTFE membrane and enhance its potential as a biomaterial. The grafted ePTFE became less hydrophobic, a desirable trait for medical implants. The grafting yields depend on the radiation dose and HEMA concentration. So in vitro studies also confirm that the grafted membrane is biocompatible and suitable for use as an implant. However, the gamma radiation made the grafted samples more brittle and rigid compared to untreated ePTFE. So future work should focus on optimizing parameters to produce modified ePTFE with better mechanical properties. So the study is to highlight the potential of ePTFE GHEMA as a biomaterial for implants. Thank you.